Hello everyone and welcome to another engine series part. Today we are looking at ENG-005, which is our engine block cutout. I do not have a drawing for this one today, but I can tell you a little bit about what's going on. I mean, everything's going to be machined as seen. The holes, however, are going to be through bolts for a quarter 20 bolts. So we'll just make sure to choose the right size bolts for that. Going into this part seems pretty not too bad actually. I see one operation from the top where we can machine most of the part. We will then probably flip it around to the bottom and machine off all of the extra stock from op1. Maybe we can try something new where we machine all the way through our part in op1 to give us a bore for op2 to locate off of, just for fun, right? Just because there's no reason why you can't touch off the X and the Y as we normally do, but we can maybe try to set our XY 0 as the back of our part there. And then we'll flip to each side and just stick it up in the vise, and we can do these grooves that we will have our glass cutouts sitting within. So I think it looks good to go. We can open up MasterCAM and get going. So open up MasterCAM 2025 and we'll let that load. We will try something a little bit different. With the radius, we have two options. We could, as we cut out the grooves, as we stand it up, we could take an end mill and kind of machine around those surfaces. Or in op1, what we could use is a ball nose end mill to machine that feature, which we might as well try that out to see what that would look like. I'm going to go to my file and I'm going to make sure that I'm in inches to begin with. And then I'm going to go file, open, and I'm going to go find my assignment. There we are. And now that I have that open, default, let's take a look at what we can do with our stock size. So before we do this, let's go in here and let's change our toolpath, or just say ENG-005. We will make this program, let's say 436.5. Part number 5. Our model is this guy, and we'll come back in and select our stock later once we have that made. So we'll go to our wireframe, bounding box, we'll click on our part, hit OK. Okay, so we have 2.375. Okay, this looks pretty simple to me. In my Z, we're going to go, I see our Y could just bump up to 2 inches, our Z can bump up to 1 inch, and then we'll have to cut our part to, let's say, I don't know, 2.5 inches. That leaves us about 50 thou on each side. So I like that. I guess that's not necessarily, we can change the orientation to my X, Y, Z. Okay, it is already correct. So let's do that. I like 2.5. It's easy to cut to. Y doing 2 inches is perfect amount on each side for our Y, and our Z being 1 inch leaves us with some material. Now I should have made sure that this is from the top. Now I probably won't let me adjust it, knowing how MasterCAM is. So let's exit out. Let's go back in and try that one more time. Make sure we turn on our solids. And in fact, I should have been having a stock level here, which I forgot to make. I wonder if I press yes now, if it'll do it there or not. Just hit OK. And that made it within my stock level. Nice, beautiful. As always, I'm just going to take my part and move it 20 thou downwards. And I'll clear out my colors. I need to set my plane, so I'll turn my stock back on and we can make our plane. I'm not sure if we've done the center of our part before. We could this time if we'd like. Yeah, let's do the center of our part. Let's just do it for fun. I know we typically go back left, but for today, let's do it in the middle. That way on the machine, you could see how you would do it if your XYZ was set to the middle of your stock. We'll call this G54, and we will make sure that this is actually to the top of our part, not the top of our stock. So we'll just drag that down. So that's in line with the top of our part. Hit OK. Good. We can go back to our stock setup area and we can select our stock as our stock for our simulation. Everything else should be good. We can go ahead and start our toolpath, I believe. So we'll start with our face mill. We can just grab the top face of the part for that. For this, we'll select a 2-inch face mill I'm going to use, but in this case, the tool is going to be, I'm just going to change this to 1.5. I could create my own tool. But in fact, let's do that. Let's just, instead of selecting a 2-inch face mill and modifying, let's just create a tool. Let's select a face mill and let's make a 1.5 with a secondary cut in diameter. It's also 1.5, but it doesn't let you select 1.5. So just say 1.51. Overall length and cutting length don't really matter that much. Everything should be pretty good. If we just want to make the upper diameter 1.5 as well, because that's kind of more what our face mill looks like, it does not matter. For aluminum with this face mill, I like 80 and 32. And we'll go plunge rate 100. This is 1x2-inch stocks, so you will need to do zigzag. We'll do a step over of, I don't know, like 90%. High speed loops. Feed rate between cuts, let's just go to 100. Stock to leave on floor is 0. No depth cuts. We'll do absolute for everything. 0.1, 0.1. Top of stock is 0.02. And this 0. Our plane is going to be actually my new plane. I'll make sure to change that for my next toolpath, and we will turn my coolant on. Hit OK. And there we go. Should be able to turn off my stock and see that my tool is cutting the top of my part. Before I forget, I'll go to my planes and set my planes to my G54 for all future toolpaths. Now I'll go and make my stock model to represent what my stock looks like before my OptiRough. My initial stock shape will be based off my model, which will be this guy. Triple click. And source operations will select our facing toolpath. And that does not look good, probably because my stock plane is checked off. Let's turn that off. Let's try that again. There we go, much better. Looking good. We'll do our OptiRough. Our machining is going to be our part as per always, and we'll do 5 thou on the walls and the floors. Toolpath control. My bounding chain will be the outside of my stock. So just like so. From outside, compensate to outside, and about, let's just say 1/2 inch. It's fine. See if I have to increase that later. For my tool, it doesn't really matter what tool we use, but let's today choose a 1/2 inch end mill. I know my 3/8 does a nice job too, but let's do a 1/2 inch end mill. This will be tool number 2. finish. The spindle speed will go, today, let's see. Let's do a couple things, okay? Because I do get the question a lot of times, Greg, how do I know what my speeds and feeds should be? It's great questions. So let's go to Harvey Tools. I'm just choosing this manufacturer. So I'm going to pretend that I have a specific tool. I know that in my shop, we typically use ISCAR, but Harvey Tools has a good chart that I know I like to use. We're just going to go to their end mills. Actually, sorry, we'll go to their products. And I'm just going to pretend that I have a certain end mill. So if you are wondering how to figure out what your chip load, and really everything comes down to chip load, right? I mean, the RPM is set by your cutting speed and your tool diameter. Now that does matter. You're not going to turn every tool as fast as you can, but typically if you're working within tools that are, you know, under half an inch and you're cutting aluminum, you're more than fine to spin that tool pretty much as fast as the machine can. So typically I always do. That's not always going to be the case, but we can get that cutting speed and we can do the calculations ourselves. So um, let's pretend that for this, I'm not sure if they'll have half-inch end mills because these guys typically sell miniature end mills. Oh, they do have half-inch end mill. Let's say I'm using this tool specifically. So whenever you're trying to figure out the speed and feed for a tool, you should know the specific tool you have. If you go to their website um, and find the specific tool, for one, look at this. They have Open in Machining Advisor Pro. So we can go there if we want. A lot of websites will have, oh, I have to log in for theirs. I think I actually have a login. A lot of sites will have actually um, little just what I say data pools where you just fill in the information of your tool, what tool you're using, what's your cut kind of like, what's your depth cut, what material are you cutting, how deep are you cutting, and it will tell you exactly what speed and feed to use. But most of them will at least have some sort of a chart. So Harvey provides this big chart, which is the one I know. In fact, you guys might want to just download this. Obviously, not every tool follows the same chip loads, but typically if you're using a carbide end mill and you're cutting aluminum, then I would see no problem with just following Harvey's speeds and feeds here. So we're always cutting out a 661 aluminum. So we can see under material, we're working with wrought 661 aluminum. So that tells me my SFM should be 1,000. So remember that your RPM is your cutting speed times 4 divided by diameter. So 1,000 times 4 divided by 0.5 tells me that the optimal cutting speed would be about 8,000 RPM. Now we still spin it faster. This is again just the recommended speed per se. So technically, based off that value of SFM, you should be running at 8,000 RPM. So SFM and chip load change depending on the tool you're using and the material cutting. Certain materials you can cut faster, you can cut more once, you can spin your tool more or less, which is why the SFM changes. So depending on the material you use, you set your SFM, you get the RPM calculation. From there, you can look at your chip load of your tool and you can see it asks you questions. Are you slotting? Are you roughing? Are you finishing? Are you slotting, roughing, finishing, right? Just trying to think here. So let's say I'm going to my wrought 661. I'm roughing and I'm using a 1/2 inch end mill. So this tells me that my chip load could be about 6 thou. Okay. Now, and you can see that their slotting, roughing, finishing is for these two groups, and the other ones are for these slotting, roughing, finishing are for those SFMs. But so 5 thou chip load And that tells you what your depth of cut can be and your axial depth of cut could be. So it tells you could do a 0.6% or 60% step over and a 1% or 100% step down. Obviously, when you're doing OptiRough, it's a little bit different. That's more for conventional machining. But there you go. If that was me, I would then go to here. I would set my RPM as 8,000 and my feed rate. I'm not going to set my feed rate. I'll set my chip load as 6,000 because that's what I recommended. And that tells me I could be moving at 192 inches per minute, which is very fast, right? That is how you figure out your speeds and feeds. It's really not too bad. If you really want, you can go to something like this site, which is one I've been using decently. It works, it's very great. Instead of having to look up the charts, I just like to use this. This is pretty good if you don't have, let's say you're just using standard tools, you're not using a specialty tool like Harvey. Again, when you're cutting a specialty metal, hard metal to cut with a special tool, you should probably follow the manufacturer's advice specifically. But for this, a lot of times if you're just cutting material and you just want a good starting point, this site has been working great for me. So I go to this, what they call Speed Doctor. So let's say I am milling aluminum. I want speeds and feeds. You just fill out what you need to fill out. So you don't really have to worry about that. You're just going to go to find the aluminum you're cutting. So say 6061. What are you using? A solid carbide? Yes, we are using a solid carbide end mill. My tool diameter is 1/2 inch. My radial depth of cut, let's just say, is normally 15% of a 1/2 inch end mill, which is 0.3. So let's just say radial depth of cut is 0.3. My max RPM is 15,000 on my machine. You could input horsepower of your machine if you want. Hit next. Number of flutes. Our tool, let's say, has, I think it does have 4 flutes, or does it have 3? It might have 3. Cut depth, let's just say we're cutting depth of 1 inch, right? I'm just setting these that might not be perfect for OptiRough necessarily. Do you want to be aggressive, longer tool life, right? Those are, you got to pay for that, I believe, or sign up for something. Chip load, automatic, it's good. You just hit next. Get cutting data. And this tells us that, they tell us that we could be at 14,000 RPM and doing a 2,000 chip load per tooth, which is probably doing a 2,000 probably because they think we're cutting really deep. They don't really understand that we're doing a OptiRough tool path. But there you go. Good starting points for your tools, right? 14,000, 2,000. To me, that's a bit conservative for the chip load, but that is about 91 and 92 inches per minute. Not bad. Not for OptiRough. We machine faster than that. But if you guys are wondering where that data comes from, that's a great starting point. As you gain experience, you guys might have heard me say this, you will start to learn what your favorite speeds and feeds are. In fact, I recommended to some students that as you do parts with me and you see me and we go into lab and we're using, 15,000 RPM, 150 inches per minute, write the stuff down, guys. Write it down, because then in the future, if you're like, hey, I'm OptiRoughing aluminum, my step downs are this much, whatever, I'm going this deep, then you can look back and be like, hey, I have this data before with Greg, I cut my part, this, I use a speed and feed. So I know that if it's the same material, it's a similar application, it should work. So myself, when I started in the industry, I always, every time I made a new toolpath with a new material, I'd write down the speeds and feeds into a notebook, Excel sheet, whatever. That way, whenever I was doing a similar application, I would just go back to the old data because I know that that worked already. So I just apply it to this new part. Myself, I like 12,150 for my end mill. My plunge rate is 100 because I'm not really cutting. We will do a rest material from one other operation, which is my stock, my cut parameters. My step over is going to be 15%. My step down will just be the entire part. So whatever that is, my part thickness was, let's just say 1 inch. And then step up will turn on. I typically like a 10% step up, so we'll do a 10% step up there. We can turn on minimum depth if we want, and maximum depth. Maximum should be turn off our stock. Right there, and then we'll want, but we will want a little bit of a breakthrough, so let's just minus another, I don't know, 50, not too much, I guess, just 20 thou. Clearance 1 inch, back feed rate 500. Everything else is good. I don't like when it does a vertical lead in. I just like the horizontal, so I'm just gonna do a horizontal. Planes, coolant on, hit OK. See what this looks like. Okay, I don't love it, so we'll fix this. What I didn't love is this on the outside. I want it machining from the outside more. I don't want to be stuck in these corners. Something's getting it stuck. So let's do in my cut parameters. Sorry, toolpath control. Offset distance. Oh, this was supposed to be 0.5, but it probably even more. So let's just do 0.75 and see if that looks better. Much better. There we go. The way it's working from the outside, and then it cuts in, helixes in nice and well, and then it cuts outwards. Beautiful. It is plunging when it cuts, but 100 is fine for that. Breaking through a little bit. Nice. I don't love that. I don't like when it does this vertical move on the inside. I just like it being horizontal. It kind of throws me off when I'm on the machine, to be honest, because I think it's stopping in the Z and then it just still goes a little bit further down. It's not the worst in the world, but so okay, horizontal, sweep angle. Why don't we do, like, I wonder why it does that. Linear entry exit. Micro lift distance. It's not the worst thing in the world, so whatever. We'll leave it. You'll notice how it steps up those walls because it's actually going to leave. It's trying to cut that radius, but it's not letting it, right? It's going to cut as close to that radius as possible by stepping up the walls without cutting into it, which will leave just a little bit of material there for finishing for our radius mill. Okay. Moving next, do some finishing. We'll probably just finish the floor with the end mill, and then for the radius and the wall, we could probably finish that with the 1/2 inch end mill at the same time. We can't use the ball nose end mill to finish the bottom because the ball can't step over, but the ball can machine the radius and the vertical at the same time because it has a straight flute, and then the radius, which will give a nice seamless finish. There, and then we'll work to get rid of the seam on the bottom. If the tools are slightly different lengths, that transition might not look the best, but we'll get that dialed in. So let's just let's start doing some contours. Maybe we'll just start with a contour on the outside. Just like so. Okay. Tool, 1/2 inch end mill. For finishing, I like 12,000, something like 50, 100 rapid retract. Cut parameters, we can turn this to wear. Lead in, lead out, turn on a little bit of an overlap. Set everything to 0.1, absolute, absolute. Absolute 0 and absolute, and our depth is going to be right here. No breakthrough. Cool, so we'll turn that on, hit OK, hit OK. That was not the depth I meant to go to, sorry guys. Mixing up the inside and the outside, so the bottom of my part just looks so. Nope. I don't know why my computer's been like this recently. It's hard to select everything. And actually, we will turn on a breakthrough. We'll turn on a breakthrough of about 20 thou. My lead in, lead out is pretty big. I could probably take down my lead in, lead out. And let's turn off this enter, exit at midpoint and close contours. That way my contour starts hopefully at one of the tangent points. That way it kind of hides the starting and stopping. And let's just do like, I don't know, 0.1, because we don't need anything too big. There we go. My tool will start at that point right here. So that start and stop will be left right there. And it will be hidden, hopefully in the radius. Looking good. I will then do some, I could do a contour in the middle. I could do, how about let's do a face? That'd be fun. Or it could be some wasted time there, I guess. What I want to teach you guys. We could do a face. We could do an area mill. Area mill might be the best. We could do contours, perhaps. Could do. I mean, I like the face, I guess. Yeah, let's play with this face. Let's see if we can get this doing something we want. But before that, and you guys might be like, why? And again, I'm just having fun with it. We want something that we could tell it to cut inside up to each radius. So an area mill might be a good bet, but it might have a lot of wasted time because you might be familiar with the retract. The easiest would just be to get it to do like, I don't know, follow this line as a contour and contour down. But then there's a bunch of air that we're cutting, which we don't want. Actually, before we do this, let's cut the inside bore, and then we'll get back to that. Okay, how about that? So I'm just going to Control C, Control V, and I'm just going to rechain, and I'm just going to select the inside of this part, which everything else should be the same. So like, bam, done, easy. Okay, now we can do the next one. So what I'm going to do is I'm going to create a level. I'm going to call this my wireframe level. And I'm going to draw some lines here just because we have this little gap here that will mess with me. So I'm going to try to draw lines to just avoid that. Right here and right here. And then I could just kind of curve this edge and this edge. And then we could do that on the other side too. But hey, let's show you some other cool tricks. Again, this is just about learning. You don't have to do it this way, but let's play with it anyways. Let's try this facing out. So let's do a face. Let's select it to wireframe chaining right here. And I guess I think, oh, facing. Well, it's going to extend both ways. We can fix that. For this, we'll use our inch and a half, or our half-inch face mill. Sorry, face mill, half-inch end mill. Don't have to use a face mill to face, right? Plunge rate is going to be 100. Cut parameters, we will do a zigzag, step over percent. We're finishing, so sure, a 90% step over is pretty good. We're going to have to come back and modify this in a little bit. We don't really care about even number of passes. High speed loops, 100. In fact, we can, whatever, 100's fine. 100's fast enough. 0.1, 0.1, top of stock, 0.02. No, top of stock is about right here, but it's technically 5 thou above that. And then our depth is right here. Planes, no breakthrough, right? Okay, so planes, coolant, make sure that's on, hit OK. Now, as we can see, our tool is crashing to an extent into our part, and that is fine. I did expect that. We could watch it just so you guys can see, and we'll see if we can fix that. Let's change my roughing angle, because right now it's cutting left to right, and I want it to cut up to down, or front to back, however you want to think of it. So I'm going to change my roughing angle to 90. And I'm going to do my, I believe I'm probably gonna get mixed up here. Is it my along overlap or my cross overlap that I'm looking for? My cross overlap. If I set this to 0, well, one of these two, I know that my end mill will not pass that line. That's the along overlap. How much does it overlap past it? I think I got it right. So you can see this tool comes in, cuts across on that line. It doesn't go past it. Typically the face mill always goes past that edge, but because I changed that along overlap, it fixed it. And there we go, in 3 passes, we got that done. Now, I'm gonna go to the other side and do the same thing, but I'm gonna show you a little cool trick. How about let's try to do something like this, where we go to toolpath transform, under toolpath transform, and let's select this facing that we just did, and let's mirror it. I honestly haven't done a mirror before. I've done a lot of the other ones, not a mirror, so just play with it. Mirror, actually, I might have done a mirror. I'm trying to think. Facing, okay. So we're gonna copy source operation, and we're gonna disable posting in selected source operation. That just means you'll see it's going to create a separate toolpath. It's going to copy the first one, meaning it doesn't delete the first one, but it's going to disable posting. So a little ghost is going to appear there. Work offset is going to maintain source operations. Geometry should be fine. Mirror, we're going to mirror over our Y0, which I'm not sure if this Y0 refers to, oh yeah, mirror plane G54. So my Y at my x-axis, it's mirroring over my x, which my x is my center of my part, which is turns out to be perfect. Oh yeah, come on, give it to me. There we go, look at that. So instead of making a new one, I just mirrored it. Again, why? You guys might be like, why? It wasn't that bad. Well, sometimes it's cool just to be able to do this stuff like that. And there obviously are times that it really is nice to use this toolpath transform, because you have to do like multiples of the same toolpath instead of making it over and over. It's perfect. And instead of having to make 2 separate toolpaths, now I just have one. If I want to change anything for this toolpath, I have to go into this original facing. I could change the parameters like the cutting speed, whatever. I will update it, and that will update this toolpath, which is really the one that posts. This one is here, but you see how it's ghosted, meaning it's not going to post. It's there. If you want to turn it on, you can just press the ghost. But it's going to post this one. And these two are fed off of this toolpath right here. So kind of a little cool toolpath for you guys, a little learning experience, I guess you could say. Now, notice how my tool starts so far off my part. How about let's actually change that? Why don't we go and change my along overlap to, well, how much further can we go? Can we go I wonder if we do 0.26. I'm not sure if it goes by diameter or radius, so we'll see what it looks like here. Does that save us time? Or is our, yeah. By the way, you can't backplot a ghosted operation, so it's just, you'd have to, what's going on here? Okay, so ghost, this one, see what's happening. My tool comes down. I don't like how it comes straight down onto it, so we'll extend that out a little bit more. We'll go to a long overlap. Let's do 0.4. Right, sorry. Post this one. Really, we're just trying to save time, right? I don't like how it's coming around on my part. So that would be, so sorry. We do want, go back to that one more time. We will want our long overlap to be at least 0.5. So let's just do 0.55, which is probably what it was at before, but this is probably what I'm gonna change. Approach distance, let's change that to 0.1, or even 0.05 would be nice. Like we don't need that much approach and exit because the part's not going anywhere. It's still the same. How many times am I gonna do that, guys? There we go, there we go, there we go. Did that even do much? Probably not. But we might have saved a little bit of time. in a job shop, every second counts. There you go. Looks nice. Okay, time for our ball nose end mill. So we'll use a contour for that. My contour is slightly cut off, so I might want to make a wireframe for this. I might just want to make an actual line because I can't select this line and this line separate. Well, I could select them separately, but it'll think I'm doing different contours. If I just do one line like that and one line like that, that'll work out well. Hit OK. And then we'll go to our toolpaths and we'll go contour and we will select this contour and making sure you're selecting it from the right side so the arrow goes the right way for our climb milling. We'll do that. And we'll choose our new tool, which is going to be a ball nose end mill or sphere. And it's a 1/2-inch sphere. Same with the flat end mill. I like about 50 inches per minute for my feed. My plunge rate is about 100. Cut parameters. We could do wear. That's fine. No depth cuts. I mean, we could do a rough and then a finish if we want, but it should be fine to do all in one. Overlap, we don't have to worry about that. Linking parameters, my depth is going to go to right here. Top of stock is 0, no breakthrough. Planes coolant on, hit OK. And I don't like radiuses when I'm just doing straight lines on my contour, so I'm just going to go back to my lead in, lead out, and just do get rid of my arc. I don't know. It's just something about it. I just like a nice straight line. However, I don't like how my tool is coming down onto my part like that. So we should increase our, in fact, probably 0.26. That way it's a bit more than the diameter, just like so. See, that'll leave us with a nice wall finish and floor finish as well. Bingo, very nice. Okay. Next thing we could do. Hey, didn't I tell you guys that we were gonna go all the way through my part today? I think we did. I think I did. So we can. How would I want to do that then? All that. I'm just going back in my mind, right? I guess we could just do a circle mill that goes all the way through after as my finishing instead of this contour. Sure, let's do it like that. Let's get rid of that contour. Let's do a circle mill. Let's select my circle. And I'm just doing this to get my tool to go all the way through my part. Probably slow this down to 50. And again, this is just more for learning. We will want a roughing operation. We will want a finish on the wall, which will be a 5/1000 finish pass. I mean, my end mill has already machined a lot of that, so we'll just, the top of stock is technically really, well, the bottom of my part right here, because we've already done a lot of it with the roughing tool. My computer does not make me happy with my selection tools right now. Apologies. So top of stock is going to be right here. depth is gonna be right here. Breakthrough. No, actually depth is gonna be my part, so that's gonna be right here. And yes, we will do a breakthrough of, let's say, 50 thou. Okay, and then that works as our finish for our inside of our bore as well. And then we'll have our stock roughed out completely. Again, just for fun. You don't have to do it this way. I think it's just kind of fun to see that we can do this. So rough it through, and that looks nice. Okay. Moving forward, we will do our next toolpath, which I got distracted. So we have everything done, the circle mill. I guess it's just, am I wrong to say that it's just the holes that are left? I don't think so. I think that's fine. So we'll do these 4 holes. We will do our drilling, not thread mill, sorry guys. Drill, and we're gonna select this hole, this hole, this hole, and this hole. Now, can I show you guys a cool trick actually? If you just hold control, so if I just go to select a hole and I hold control and click it, it'll click every single hole that's the same diameter. Just a little quick trick for you guys. Now, in the end, this is gonna have to be, I believe these are, I guess they're 1032 holes, right? Because the top of our, am I second guessing myself? The top of those parts were definitely 1032. Am I correct to say that? Let me see here. 1 second. TM 436. So this connects the top of our part. So I'm looking for ENG1. That's fine. My drawing. And the top. Yeah, okay. The quarter 20 was from the front. This is 1032 from the top. Okay. So this is a 1032 tab or through hole. Okay. So whatever. We'll start this. Keep that in mind. Tool. I just had a thought in my mind. I want to make sure. By the way, this ball nose end mill, I should change this to tool number 3 while I'm at it. Finish, and we will select a library tool, and we can use a spot drill. That is a 3/8 spot drill. We'll go 12,025. This tool will be number 4. Cut parameters, drill counter bore, linking parameters, retract 0.1. Actually, no, let's do, well, let's figure what size hole we're going first. So let's go to my the site. Let's go. In fact, I probably have a tab drill chart of some sort for you guys. That's not the one I want. Sorry. Boop. Okay. So for a 1032, our clearance hole is going to be 1032. Clearance hole for a close fit is going to be a 0.196. We're going to go for a close fit today. So we're going to go at number 9.196. So 0.196. Let's do just a little 10 thou chamfer just to make it a nice starting point, or just like a nice clean edge. So I'm going to do this. I'm going to say my finished diameter is 0.196 plus, actually just do 5 thou chamfer on each side, so a 10 thou, just to kind of help get rid of the burr, and that will calculate how deep it needs to go. We're not going to do tip comp. We will make sure our coolant is on and hit OK, and bam. I don't really like how it's doing this crisscrossy thing. It's a little bit inefficient. We can go to our geometry and we can change the pattern to, let's do, is there one that just says, okay, let's do something like this. That's fine, doesn't really matter. Technically, it's best to start at the back left because that's closest to where our tool changer is. It's the quickest hole to access. There we go. Just make sure that that's not cutting too close to that. Looks good. I'm just going to copy and paste this, and I'm going to go and select my next tool, which is a drill. I think it was a 0.196. Number 9 drill, that sounds right. We'll make this tool number 5. This can run at, let's do 8,000 for this drill, but the diameter of the tool, which is 0.0019 in thousandths of an inch, right? That's my feed rate. We'll do PEX, chip break, pecking at 0.2 is fine. Put the diameter of the tool, retract 0.1, top stock is there. Depth, well, it's to the bottom of the part, so we'll go down to here, right there. You do want tip comp on, and we'll break through, let's say, 50 thou. Now, one thing I am worried about doing so is if my, I guess we have stock on the bottom, never mind, we're not gonna hit my parallel, so we are good, not to worry about that. That looks good. We are good, I think, for my op1. We can go to my tools and make a new toolpath group, and we'll call this one op2. At the start of my op2, could make a new stock model just to kind of see where I am at with my tool or with my part. Based off stock model 1, based off of all of these toolpaths. Okay, my part's looking nice and good so far. Kind of curious why it is not shiny on this inner wall, so it just makes me think about this toolpath. I just want to make sure that there's no stock on my walls. It's probably just a glitch in the system, to be honest. Sometimes happens. Okay, we'll move our starting this down here, and we will just face off the back of our part. Now you can see we cut through the bottom of my part. So this is accessible now to set our offset for op2. We'll still have to set the offset off the bottom of the part and then move it up the thickness. But now for my X and Y, instead of measuring off my vise sides, my front of my fixed vise and the left of my fixed vise, we can just drop our probe down in the center of the bore and measure off that inner bore. So sometimes it's a really good option. If you have a hole in your part, you can just make that hole go all the way through your stock and then set that for your, use that as your op2. Now you guys might think, hey, my assignment, that would be a perfect way to set your op2 plane for your big assignment 1. So in doing so, actually, I'm just going to get rid of this right now, and we'll do this, and we'll do, to select the inside of this bore, I'm going to grab onto this bore, and I'm going to hold Control, which, or Shift. If you hit Shift, it'll let you select the center of that, and then we will rotate this guy. Now, does it matter which way X and my Y faces? No, because this part is symmetric, so it doesn't matter how the operator puts this, just as long as the, let's say the cutout is facing us, is really all that matters. Hit OK, call this G55. And then manual, we'll do this as 1. Okay. Now I'll go to my planes, and I'll make sure I'm selected onto this plane, and I can start my toolpath. I might just grab this first toolpath, copy it, and paste it below. I already made this toolpath once. I'll just change my plane to be my new plane. I'll do my cut parameters, or my linking parameters. My top of stock is a little bit different, so I will make my top of my stock the back right here. My depth should be 0. And I will want to turn on step downs, actually, is my last thing. So cut parameters, depth cuts, we'll do a max 0.1 and a 1 finish cut at 10 thou. It's good. Keep tool down. So it's 3 cuts in the end. Sure, that works fine for me. After that, we can turn back this stock off. That's it for op 2. We could chamfer the part, but we'll leave that for us to chamfer ourselves just because we don't have much time making these parts. We will then go back up here and select and just say new toolpath group. We'll call this op 3. Okay, and then we will get rid of that. If I wanted to, I could make another stock model. I guess that's what I've been doing, so might as well. They're so easy to make. When I put this in, I'm going to stand my part up like so in my vise. So let's make the X. Let's have some fun. No, let's keep it simple just because I know I probably won't be able to give you guys all my time. So let's put my at the corner of my part, just like we like so. G55. And we should be to go. So we'll just do a contour for this when we do this kind of slots. Nice and simple. We'll go based off our solid and we'll just grab this inside wall like so for my tool to follow. And then we will use specific tool. We're gonna use, well, we know that's a 1/2 inch. I'm not sure exactly which one we have. I could go to my Fusion file here and see what this inside. This diameter is 0.5, so we can't use anything bigger than that. Which I'm not even sure if we have one of those, but hopefully we do. We will figure it out if not. So ideally, I'm going to filter for a slot mill like so. And if there's none here, we're going to create a tool, which is more than fine. So we'll just say create tool. We're going to do a slot mill next. Let's say that this is going to be a 0.5 with a overall length 2, doesn't really matter that. The thickness of this tool, well, we're going to want it to be the thickness of the slot. Hoping that the thickness of the slot is something nice, 0.1. Okay. Let's just go with this. I might have to change this based on what tools I have available. I will warn you. The shank diameter, let's do 0.25. And that should be good. We'll just call that our tool. Tool number 6, slitting saw. We'll go, we'll slow this one down a little bit. We'll do 8,000. Actually, 8,050 is probably a fine speed. Sorry, not 50, 50. Plunge rate 100. Cut parameters, where is fine. That's good. Contour type shouldn't be set to 3D. Now that sends off alarm bells when I see it set to 3D. Something might be off with my plane or my geometry selection, which made it think it was a 3D contour. I like that. Top of stock is right. Oh, that's why, because my plane's probably set wrong. So it, I thought I made a new plane, didn't I? Well, that's why I thought it was 3D. Okay, so let's do this for now. It's not going to be happy with me. That's fine. Let's go to my plane, see what's going on here. And G50, oh, I see. G56, we want to call this. And we'll 2 levels, toolpaths, parameters, planes, G56, that's what I'm looking for. There we go. Coolant should already be on. Hit OK. Now we just still have to modify the depth, which is why I messed up, because I noticed that was a mistake there. So there and there. No breakthrough, just like that. See that we're cutting that. Beautiful. My other side is the exact same. So really what I could just do is I might just take this entire, I just copy this entire group, or should I go to group? What happens if I do that? What if I go, well, doesn't really matter because this is gonna be the same. I'm gonna have a stop and I'll flip my part. It'll be the exact same toolpath. I might as well just throw, I get this exact same contour just right next to it. And then I could do, like, in my parameters, I could actually just say minuscule values. I could just say what am I looking for? Can text. Oh, I could do a stop before. Turn that on. So that means before it does its toolpath, it'll stop it. I can flip my part in an ideal world, and it will just machine the second one. I don't have to have a new plane. I could set up a new plane if I wanted to. In fact, to make this look like it's a completely machined part in MasterCAM, I would want to do the same thing. You can make another one, but in reality, I know it's going to be the exact same. For today, does that matter? Should we just do it to say that we've done the entire part? Probably. Let's just do it the right way anyways. So I'm going to go and create a new toolpath group just because it looks nice. Then you could verify all your toolpaths aren't crashing and stuff like that. We'll just move this down to here and then just, I guess, set up a new plane on the other side like so. Call this G50, I had 55, 6, 7, 3. It could be the same. I could make it just the same offset, which I probably should do. So you don't have to set a new one, which, sure, I'll do it that way. So I'll just make this G57, even though it's technically a different plane. It's the same. So I'll just make this technically, well, actually, let's call this G56-2. Really, we won't set a G57. We'll just use the same G56 coordinate because it's going to be the exact same for our part anyways. So yeah, there we go. Toolpaths, planes, just switch this to G56-2. And then it looks like we just have to flip our side. There we do. And there we go. We can now just grab this, verify that this works. Beautiful. The holes look a little weird, but it's because I changed the size on the fly. Everything else is good, guys. That is it. We can now just quickly make a setup sheet, I guess. So let's go and do that. we're going to use an old setup sheet. We'll just save this as ENG5 job sheet before we make any changes. Okay, this is 1x2 cut to 2.5, if I remember correctly. One engine 5. This is called engine block cutouts. Get rid of this for now. Okay, so tool 1, I'm gonna try to bring this up. Tool 1 is a 1.5 face mill. Tool 2 is a 1/2 inch end mill. Length of the hole doesn't really matter, but it will need a decent amount of flutes. It's cutting all this at once. So we'll need a point. Ooh, I wonder if we'll have that. We might have to step down. We'll see. .85 of flutes. Tool 3. 1/2 inch ball. Tool 4. 3/8 slot drill. Tool 5 is a number 9 drill. Number 9 or 0.196 drill. Op 1 0 0 is. I did throw that in the middle. I just call it mid stock. And it is 20 thou from the top of the stock. Op 2, well, we're going to call this 0 is center bore. Center bore. And this is going to be top parallel. And that would be the thickness of our part. 0.831 inches. Or 0.831. Positive. Op 3 is we got an XYZ here. Zero, zero, zero. Left side part. Back part. You could just say top of part 2. Make it better. Align op 1 and vice jaw. When we go to machine this, we'll try to use Yeah, I'll try to use both vices. So let's see, line op1 in left vice jaw, align 2.5 inch side in X, 2 inch side in Y, and 1 inch side in Z. Ensure 20 thou plus 831.85. So 0.02 plus 0.831. We also break through what 20 thou. We need a minimum. Ooh, it's gonna be tight. We have 0.871. Let's say, do we make it that close? Ensure. Well, we might have to. Ensure 0.88 inches stock of ice. That's gonna be tight. That might only leave us with about 10 thou based off my calculations, but we will work with what we have. Op2, use, op2, we'll just say flip 180, channels, let's just say cutouts, either cutout, operator. We will then rotate part, so cutout faces. I think that's pretty good. We can always change that time of. We could add our tolerance specifications, but for today, that will be good. I think that is a good setup sheet. So we will hit save and we will call it there. So that is it for the Engine 5 part. See you next time.